Hey everybody, this is Mr. Backstrom, and today I want to take a look at one of the review problems from the Test 4 review. And this says find the area bounded by the graphs of these equations over the given interval, and they want us to compute our answers to 3 decimal places. So they give us the function y is equal to x squared plus 4. They give us another function that says y is equal to 2x minus 2, and they want us to go from -1 to 2. So the first thing I would do in this case is I'm going to graph this. So let's put that first equation in there, which is just x squared, x squared plus 4. And the second equation is 2x minus 2, 2x minus 2. And to get a better window, I'm going to do my window key, and I'm going to go ahead and use these x values to set my window up. So this is from -1 to 2. So I'll change my x minimum value from -1. My x max problem to 2. And I won't mess with my y's yet. I might end up having to. But let's go ahead and graph this. And it definitely looks like we're going to need to, oops, let me go back to a standard. There we go. And then let me go from here to -1 to 2. All right. I hit graph, and so I'm looking at this area here between these two graphs. And the way I'm going to solve this is by finding the function that's on the top, and then subtracting the function that is on the bottom. And then we're going to take the definite integral from -1 to 2 of that. All right, so let's see how this goes here. To find the function on top, I'm going to hit trace, and it'll tell me which one this is. So that's the x squared plus 4. And then on the bottom, just hit down, and that's going to be the 2x minus 2. So we have y is equal to x squared plus 4, and y is equal to 2x minus 2. And I'm subtracting the second one from the first one. So let me go ahead and copy this over to my whiteboard. And right here. All right, there we go. Okay. All right, so it's the integral. The definite integral is going to look something like this. -1 to 2 of this function here. Remember, that was the function on top. So x squared plus 4. And then we're going to subtract the function on the bottom. That's going to be 2x minus 2. And dx. All right. So if I distribute this negative here and then I simplify this a bit, I am going to get from -1 to 2. We'll have the x squared term. And then we'll have a minus 2x here, minus 2x. And then we'll have a plus 4, and a negative times a negative is a plus, and a plus 2. This is going to be plus 6. And dx. And then we simply apply the antiderivative, which is the power rule. All right, and so that's going to become, remember, we add 1 to the exponent and then divide by 3. So that will become x cubed, 1/3 x cubed. And then this will become minus, that's 2x squared over 2, which is just going to be x squared, plus 6x. 6x. And we're going to evaluate this from -1 to 2. So let's go ahead and actually use our calculator for this. So what I'm going to do now is I'm going to go back to my y equals. And if I want to leave those two functions in, I can. I can just put this last one here. So that's going to be 1/3. And x cubed minus x squared plus 6x plus 6x. All right, enter. And then we're going to go to my second graph, which is my table. And let's delete what's already in there. And now I'm going to evaluate it at 2 and -1. All right, so this is going to end up being 10 2/3 minus a -7 1/3. And that will give me my final answer using the fundamental theorem of calculus. Remember, we evaluate this at 2, the upper limit, and then we do a subtraction, and then we evaluate it at -1. Another way I can do this, if I don't want to carry these numbers over, is I can go to the main screen here, and, let me double check that. Yep. Go back to the main screen here, and I'm going to do vars, y variables, and go to my y3 function and say evaluate this at 2 minus vars, go over to my y function and my y3 minus the function evaluated at -1. And I get 18. So that is my final answer. All right, if you have any questions, let me know, and I hope you have a great rest of your day. Thanks.